Volto outra vez, tive que parar o vídeo, não estava a conseguir voltar à apresentação. Então, o que é que acontece na Terra em termos de ventos se não houvesse uma Terra giratória? Basicamente, o ar quente subia nos trópicos e depois voltaria a baixar nos polos. E por isso, como o ar quente que baixa nos polos teria que ser reposto, mais ar quente dos trópicos iria para os polos e haveria uma célula de convecção em que o ar subia nos trópicos e baixava nos polos. E essa seria a circulação. No entanto, a Terra gira e por isso tudo isto vai ser desviado para a direita no Polo Norte, no hemisfério norte, e desviado para a esquerda no hemisfério sul. Vamos ver nesta animação o que é que acontece. Peço-vos um bocadinho de paciência. As animações são um pouco pesadas e isso demora um bocadinho a abrir. Vamos ver se agora abre melhor. Ótimo. Acho que desta vez estamos com mais sorte. Esta é uma das razões que estas animações são muito pesadas, que eu resolvi estas animações passá-las como vídeo, para o caso de vocês não conseguirem ter internet suficiente para abrir as animações. Então vamos ver então o que é que acontece em termos de ventos numa Terra giratória.
Ocean circulation patterns. The circulation of ocean water is one of the most important mechanisms for transferring heat around the world. Major ocean currents move warm equatorial water toward the poles and bring cool water from the high latitudes back toward the equator. Here you see the basic pattern of surface ocean currents around the margins of Earth's ocean basins. Warm currents are shown with red arrows, and cool currents are shown with blue arrows. A current is classified as warm if its water is warmer than the water through which it passes, while a current is classified as cool if its water is cooler than the water through which it passes. Notice that in the mid-latitudes, warm currents are found off the east coasts of continents, while cool currents are found off the west coasts of continents. The major gyres of ocean water you see here are initiated by wind blowing across the ocean basins. Here you see the major belts of wind and pressure around the world. Notice that the general pattern of ocean currents matches the general pattern of wind. In the tropics, the easterly trade winds push surface ocean water from east to west across the ocean basins. The Coriolis effect deflects these equatorial currents to the right in the northern hemisphere and to the left in the southern hemisphere, moving warm water toward the poles along the east coast of continents. In the mid-latitudes, the westerlies push the surface water back across the ocean basins from west to east. The Coriolis effect deflects this now cool ocean water back toward the equator along the west coasts of continents. The large gyres you see here are the most important ocean currents in terms of global weather and climate patterns. In addition to the westward moving equatorial currents we just saw, equatorial countercurrents are found near the equator in the Pacific, Atlantic, and Indian Ocean basins. These currents return some of the warm equatorial water back to the east side of the ocean basins. High-latitude ocean currents are locally important to weather and climate. For example, the Alaska Current circulates relatively warm water high into the Gulf of Alaska, and the Oyashio Current brings relatively cool water toward Japan. In addition to the surface currents we've just seen, there is also a general flow of water in a deep ocean conveyor belt circulation. A shallow current of relatively warm water slowly moves from the Pacific Ocean through the Indian Ocean and into the North Atlantic. In the North Atlantic, this shallow current cools and sinks. A cold, deep current then flows south out of the Atlantic Ocean, where it joins the flow of deep water near Antarctica. Some of this deep water eventually flows north back into the Indian and Pacific Oceans, where it rises into the shallow warm current.